Okay, so here's a question dealing with uh, factoring a function, but more specifically asking, is this a factor? Okay, and when you look at this expression, right, we've got four terms. So the question right off the bat is, can I factor this by grouping, right? Because if I can factor it by grouping, and this happens to be one of the factors, then success, right? Or if not, then it's not. Um, But one thing that we've learned about synthetic division is that the reason that we do division is to determine if something composite like this is divisible by something like that, right? And again, take it back to the first thing that we talked about with doing division with integers. Is 20 divisible by 6? Well, does 6 go into 2? No. Does 6 go into 20? Well, it goes in 3 times, but we end up with a remainder, right? So the same concept applies to synthetic division with polynomials. If you want to know if something is divisible by a number, or if you want to know if something is a factor of a bigger function, do synthetic division, and if you end up with a remainder, then it's not a factor, right? Plain and simple. So let's do that. Let's set up our synthetic division problem. Remember that when we do synthetic division, we use the 0 from the factor. I'm going to say that again. We only include the 0. What's the 0 from this factor, right? It's -3. So then we draw our fraction bar, our upside down fraction bar. I'm going to make this pretty long so I give myself some room. And then we write coefficients, right? The coefficient here is 1. And then the next number I write is going to be a 0. Why am I writing a 0? Because we went from the x to the fourth to x squared. You can't skip over x cubed, right? Now there is no x cubed in this polynomial, but we can write that as 0x cubed. And we need to have every exponential term of x needs to be represented in this dividend, okay? So that's why we're using the 1 here. We're using the 0 here. Then we have a -10, right? Include the sign that comes before it. That's our x squared term. Our x term is a -2, and our constant term is a 4. All right, and I may have gone a little crazy here with how long I made this, so we'll shorten that up. Okay, so here we go. We take this number and we write it down here, automatic every time. -3 times 1 is -3, and then we add, we get -3. Then we do -3 times -3, well, that's fine. -3 times -3 is +9, and we add. Here we get -1. Then we do -3 times -1, which is +3. We write that here, and we add. -2 plus 3 is 1. Then we do -3 times 1, which is -3, and we add, and we end up with a 1. So what do we see? This last spot right here, this is always our remainder. And if there's a remainder when we do a division problem, that means the thing that we were, sorry for the ambiguous term here, but the thing that we were dividing by is not a factor of the bigger part here, of the composite. So there's a remainder. Therefore, x plus 3 is not a factor.